Go. Corey. 5. Number 5. What else? 15. What else? J. Reeves. 11. 5, 11, 15. Anything else? Going once? Anything else? Going twice? All right. So starting with number 5, then going to 11, then going to 15. I want you guys to go ahead and look at your packets to see if you can explain first. Maybe not going up to the board, but maybe just walking through the process. Does anybody have an explanation for number 5 or how they did it correctly? We have a couple. I saw Jonathan's hand first. So go ahead, Jonathan, walk me through. Good. That's okay. Okay, so you guys already formed the polynomial earlier? Do you have what number you formed it in? Number 3. That's okay, because we're on number 5. Okay, and it's only the second degree Taylor polynomial, so we stop it. Good, so then you would only end up with which one? Oh, I didn't realize the difference. So this one has an x squared instead. Got it. So then when you go to plug in, so this would be g of x, right? So now you're doing g of x squared. So negative 1 plus 2/3 x squared plus 3, is it minus 3 ninths? Plus 3 ninths? Okay. I just wasn't sure if it was alternating. Sorry, I was just double checking that we had said it right, but then I can tell. So final answer is because we were supposed to stop at the second degree. Good. Does that make sense? Okay, number 11. Now careful, it says which of the following are equal to, right? Nice thing is none of them say none of these. None of the options or none of these. That helps out just a little bit, but bless you. What are you guys looking at when you look up here? Power series, that's a good first thing to think about, right? So the power series of this guy builds off of this guy, 1 over 1 minus x, which equals what? Okay. And then what's going on to that guy? I heard derive, I heard negative, I think that's all I heard. So if we derive, what's going to happen? You're going to bring down a negative 1, which is negative. You're going to make it to the negative 2, but then you're not going to forget chain rule. So you're going to multiply by another negative 1. Yep. And so the derivative would be, what's the derivative of 0? Sorry, of 1? 0. Of x squared. And then pretty soon, if we were to keep going just in case, that'd be 3x squared. Right? So who does that match with right away? Okay, so he's a for sure. We can go ahead and narrow down those two. What else? Okay, because maybe he's a little too hard to see. So if we plug in 0, it'd just be x to the 0, that'd just be 1, right? If we plug in 1, that would be 2x. If we plug in 2, that would be 3x squared. How's he looking? Pretty good. So we can cross off that one. What are they looking at? They're looking at, couldn't this guy, the answer key said A for number 11? Oh, okay, I got super confused. I'm like, that's bad. Really bad. Anyway, coming back. They're seeing 1 over 1 minus x. Look on the inside. Isn't that just 1 over 1 minus x? And then they're thinking, well, wait a minute. If I take 1 over 1 minus x, couldn't I just square?
Oh, look at that.
That makes sense.
That's extra
Now,
nice.
would we do this by hand? And the answer is, why not? You would have to do polynomial multiplication with every single term, and there are infinitely many. But is it technically true? Yeah. 1, 2, and 3. Dun, 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 dun. You guys are funny. You really didn't see that. Huh. Yeah. Oh, let's go to 15 first, but then we can go 16. Okay, number 15. I was back there writing them down as people asked them. Sorry. That's why I'm pointing. Nice thing is, the information that we're going to use for 15 is important for 16, so that's okay. Number 15, what do you guys notice? I mean, they gave you this function, but what do you notice about what they're actually asking you to deal with? What's missing? Yeah, the beginning of the function's missing. It's just the ending. Right? So if they don't have the beginning, could it be any of the Taylor polynomial approximations?
Yeah.
If it didn't have the beginning? I suppose it could be a Taylor polynomial approximation of the function f of x minus 1 minus x squared over 2 minus x cubed over 7. I guess it could be a polynomial approximation of that, but they're not saying a polynomial approximation of this minus that minus that minus that, right? It's saying a polynomial approximation. No, because it doesn't have the first 3 terms. So it can't be A, B, or C. Now we're down to error. Why is it? Oh, error. This one says f of x equals, well, to be honest, is this alternating? I thought it was when I looked at it quickly yesterday, but is it actually alternating? No. Plus, 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 minus. So it's not actually alternating, which is why this needs the plus dot, dot, dot. If f of x is equal, not approximate, is equal to this entire thing, if I take this term and all the rest, wouldn't that be how far off using these 3 to approximate would be? Right? So if this equals that entire thing, I'm not technically using the alternating series estimation remainder theorem thingamabob bound. Anyway, so just throwing in words now. I'm not using the alternating series remainder bound. What I'm using is, well, if f of x equals, and if I only use the first 3 terms, I'm missing all of these guys. I'm missing error. Cool. Associated with, well, taking the first 3. This is what's left. So it had to be D. Okay? Number 16 says, do I need to see that? Which of the following are true? They're kind of general. We could use the alternating series remainder. True or false? Because we just talked about it's not truly alternating, right? Unless we did something like subtract 2 terms. But no. There's no proof it'll keep alternating. So no. 1 is a false, which means I can go ahead and... Nice. Go team. 50% chance. Number 2. Number 2, f has a relative minimum. Pause. Just go AB. Go AB on me, right? Relative min. What do we know? First derivative equals. Thank you. Second derivative must be. Now, must it be positive to have a relative min? No. But this is the only way I can prove, looking at a Taylor series, that it is a relative min. So if that's not there, then I can't do anything, because can I look before and after with a sign chart? No, I don't even have, no. So how do I look at or see the first derivative? I mean, I guess we could derive and plug in 0, or we could look at the first degree term and say, what's the coefficient? The first degree term. First degree means x to the 1 power. What's the coefficient? It's okay. Because x to the 1 is, okay, shh. It's okay. X to the 1 is missing. So what's its coefficient? Good. But could we also have taken f prime, which you guys aren't bad with that, and you could have found 2x over 2, right? Plus 3x squared over 7 plus. What's going to happen when I plug in 0? So either way you do it, you could just take the derivative. And this is what a lot of you guys got messed up on this test. You didn't realize when it asked for the derivative, just take the derivative of the series. That's fine. You guys remember the FRQ? There was the F, there was the G. You were supposed to take the derivatives and then find the relative min. This is great practice based on that test question that a lot of you missed. So the first derivative is 0. Check. Not enough.
Second derivative.
All right. So who's the second derivative? You can derive it again if you want. And if you take the derivative again,
Plus 0. So then it's 1.
because that'll be just showing all the rest will have x. So when I plug in 0, so that's true. Could you have also looked here? How would we have found 1 looking at the 1/2 coefficient? Good. Right? We would set it equal to the general term, which would be the derivative, the nth derivative over the nth factorial, and then simplify. True?
Yes.
So either way, also would have been 1. But you could have just derivative. Okay, so number 3. If, you've given me a fact. If f of 6, the sixth derivative of f of 0, at 0, is 2, then the coefficient of the x to the 6th term would be 2/6. Need it to match, right? So they're not telling me the coefficient, which I can kind of play around with a coefficient and solve for stuff, right? They're telling me the actual derivative. The actual derivative needs to go over the actual factorial, which needs to be multiplied by x to the 6th. So is that true? Nope. Which is why the final answer is, hopefully, A. All right, those are the only questions that I've heard from you, 5, 11, and 15, and now 16. But go ahead. Is there something else that we want to talk about? 3? Anything else besides 3? That's okay. Okay. Let's go back to 3 just real fast, then we'll skip ahead to 18. They tell us g of 0 is -1. They tell us a general formula for the nth derivative of g at 0. Is this the one that we did? Did we do this? Or no, we might have done a different problem on it.
No, we did this one.
I don't remember. Okay, so remind me real quick, what did we do? Yeah, because I need to go ahead and do the nth derivative all over the nth factorial times x to the n, right? So then I would go ahead and for the first term it's just -1, so anything without a -1, never mind, they all do. That's nice. Now, go ahead and go to the first derivative. Okay, first derivative would be, I don't remember doing this one. I don't think I did. I think you guys did. And then 1 plus 1 all over 3 to the 1 times x to the 1. And we need to have that nth derivative be all over, well, 1 factorial is just 1. So that'd be 2/3. There we go. Well, I mean, to be honest, the 1 factorial doesn't necessarily cancel it out. But once you go to the second term, you'll pretty much see what's going on. Because your second derivative, 2 plus 1 would be 3. 3 squared would be 9 all over. Then you need your 2 factorial. Those cancel. And so now we have the 3/9 and we're good to go with, I think, right? Okay. Oh. Well, no. B won't work because the 2 factorial. Oh. Oh, that's mean. I don't think I've seen the AP do that before. That's a little rough. All right. Maybe they would. 18? Like my dramatic flair? Okay. Coefficient, that means the whole thing, right? Oh, they gave you the coefficient formula. Okay. And they need you to find the, is that third derivative? Okay. So third derivative, the coefficient of the third derivative would be the derivative of 2 all over 3 factorial times, what am I doing, like x minus 2, I guess? Not that you need that. Okay, looking at the coefficient, right? So we're going to set the coefficient equal to, take away the x minus 2 cubed, it's not necessary for the coefficient, a sub 3, because it's the nth term of the Taylor series expansion. Wait, nth term, not the nth degree term. Hold on. Nth term, not the nth degree term. It wants us to find the third derivative. The third derivative would go with the third degree term. That would be the fourth term, though, of the expansion, wouldn't it? I would plug in 4, unless they just didn't word the question well. Because the first term, technically, would be the 0th derivative. What am I doing of f? Would be f of 2. The second term would be f prime of 2 all over 1 factorial x minus 2. The third term would be the second degree. The fourth term well, they start when n is 0. Oh, I see what you're saying, but that's the degree. See, I'm looking at the degree versus the term. I mean, you guys already solved it out. Did it work with 3? C using the third degree? Is it with 3 factorial, Jason? No, but I just need to know, it is with 3? Okay. Sorry, I do a lot of pre-cal kiddos, and in pre-cal we talk about the nth term being, and so I assume that they would always say the nth degree term. I'm not sure if I've seen an AP calculus question say the nth term. Well, I guess we can go with the 0th term. That's okay. All right, so let's just assume it's the degree term when it says the nth term. So it would say 0th, not first, so it wouldn't be logical, be more mathematical. So we do 2 times 3. I mean, the nice thing is with the fourth, it's not even an option, right? Because there's no 5 to the fourth. So I guess that kind of helps narrow down the options a little bit. But then 3 factorial all over 5 cubed. Guys, you just multiply the 3 factorial and it ends up being squared. Dun, 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 dun. Pause. Have you realized how many times this very dilemma has come up and you guys have not gotten it the first time? So, problem on the AP. Talking about the coefficient versus the derivative. What are you supposed to be doing in a colored pen? Making a note to yourself so that you know to study it because it's a weakness? Marking this idea, coefficient and nth derivative. Because I think this is at least the 3rd or 4th time it's come up just in like our practice problems. Not of this specific packet, but throughout the chapter and then here. Kyle. 17. Katrina, do you have a question on this one first? No. Okay. Oh, good. 17. All right, Kyle, go.
All right, so I forgot B, and then apparently answer B.
Hold on. Wait. I don't care about what the answer is. I care about the process.
So, like, when I was doing it, I plug in, or just find each derivative, right?
You do need to find derivatives for the tailored approximation, true.
My question is, how do you find the second?
Okay. Well, let me ask first of all, how'd you find g of 0? Good. So you can go ahead and just put -3. How'd you find g prime of 0? Because the graph is... Did I write something wrong? Oh, thank you.
I don't know why they would even give you G's. Oh, they didn't change.
No, that is important. That's super important. Thank you for reminding me. I didn't look at that. I should have. It's not -3. Thank you. I forgot I looked at this yesterday. About 1. I need g of 1. I need g prime of 1. I would have seen it eventually with the -1, but thanks, John. It did some time for sure. And then what are we doing second degree? G double prime. All over 2 factorial times x minus 1 squared. Okay. How do I get g of 1 if g is the integral of f of x and I know that g of 0 is -3? Wouldn't g of 1 equal g of 0? Hey, integration is net change again, cool kids. Are you still as bad at it as you used to be?
No, definitely not.
This is being applied to a Taylor series, so be a little bit encouraged. It's a little harder, but this integration is net change. Well, I need to get to 1, and I have 0. And an integral is what I need of the function given. Does that make sense? So how do I get to 1 from 0? Well, first of all, 0 is -3. Second of all, how do I integrate if it's not geometric? It is geometric. So I need to go ahead and say, what's the area of Mr. Trapezoid? The base is just going to be 1. Height 1 is going to be 4, which they should have stated it. The AP would be very clear about the points, but that's all right. We're assuming what we see is what we get. The slope, now, we know better than just to assume what this is. Haven't we been bitten in the butt a few times before, like last year, that we assumed what that was and it ended up being like a fraction that's close to it? Need water? Okay. So then this point is 0, 4. This point is 0, 4, and this point is 4, 0, right? Which means the slope is -4, +4. Okay, we can go down 1 over 1. So what is this height now that we've figured out that? Good. So we can go ahead and do 4 plus 3. So then g of 1 would end up being 4 and 3 is 7, 7 over 2 minus 6 over 2. So that'd be 1/2, yeah? Good. Okay. How do we find g prime of 1? Hey! Fundamental theorem of calculus. Derivative of g is f. And the derivative of g at 1 is f at 1. And what is f at 1? We just found it. 3. Okay. G double prime. Pause. Haven't I taught you guys for these accumulator functions to write out g is the integral, g prime is equal to f? What would g double prime be? And f prime is the slope of the tangent, and the slope of the tangent we already talked about. Match it. So forget those guys, so they start at -3. Then we get to these guys, and we have, I think he's supposed to be centered at 0. But just to make sure, we have 3 times x minus 1, and we have -1/2. See? Double checking. Oh, yeah. No. Okay. It's okay. It's easy to do. Katrina. Yeah. What was your problem, Gabby? Okay. How many of you guys going over the questions has helped you in some way, shape, or form so far? Okay. My kid's not raising hands. I just want to double check. Just listen carefully. Hands down. Let's do it one more time. Hands down. For how many of you has answering the questions caught some mistake so far? Okay. I just want to make sure you're not bored. Well, let's go ahead and do this anyway, because some of you might not have any remaining questions. So let's go ahead and uh-oh, hold on, what's going on? Oh, good. Okay. Thank you. Take one, pass around. All right, the packet for today, for tonight's homework, is coming around polar area, which is laying the foundation, number 2. So if you guys are bored, you can start working on the review, number 2. Number 14, I just wanted to make sure it's at least been helpful to everyone up to this point. Graphing calculator, go team. We want to use the Maclaurin to estimate e to the x for x on the interval 1 to 2. Which of the following would be the smallest integer value for m in the remainder theorem? R sub n is less than or equal to. What do you guys see in that theorem? Yeah, let's start there. What's the Maclaurin for e to the x? All right. Why don't you just go ahead and put it on top of the CalcBC? Tomorrow you guys can make sure you has it. Okay, on the interval 1 to 2, which of the following would be the smallest integer value for m? R is the remainder. That would be also seen as the error, right? We have the nth degree that's being used to approximate the n plus first over n plus 1 factorial. That could be Lagrange in some way, shape, or form, right? Okay, so who's this m referring to? What's missing from, whether we think alternating or Lagrange, it's not alternating, so let's not think that. If we're thinking Lagrange, sorry, not alternating. What am I trying to think of? I was thinking of the interval of convergence, but that wouldn't be error. Okay, so Lagrange. What are we missing? We have the x to the n plus 1. We have over n plus 1 factorial. They wrote it weird. Who is this guy? Isn't that the n plus first derivative? Not of 0, but of... No, I don't see the derivative. Do you guys? You see something in its place. You see something in its place. Because they wrote it weird. But shouldn't it have been written? They wrote him there, and they pulled this guy out. You see it? Because that's not a derivative. That's just x to the n plus 1. That's just the x component, the degree, right? So m is something to deal with the n plus first derivative. If this is Lagrange, that makes sense why we're not looking at 0, because then we just go ahead and solve it. So they're asking for the smallest integer value for m in the remainder theorem, the n plus first derivative. Huh. How are we going to do that? Mm-hmm.
Oh, wait.
We're trying to minimize the n plus first derivative.
Don't you just use the small numbers that they give you? The one?
The at the one?
The what?
But who is the n plus first derivative? Who are we considering? Uh-huh. And e to the x anywhere. E to the x is strictly what? Increasing. And so if e to the x is strictly increasing, what would be the minimum value of e to the x on 1 to 2? E to the 1. So e. And so e is equal to what? 2.71828. 2.71828. Now we have to think of integers. Hold on, watch the wording. Which of the following would be the smallest integer value for m in the remainder theorem? We just talked about e being the minimum. So the smallest integer would be 3, because it hasn't made it yet to 2. Did you guys grade it, though? Is B the right answer? For m? But why e squared?
I don't know.
Because e squared would go up to 8, but instead of, because it wouldn't go down to 7. But the n plus first derivative is going to be e to the x. We're estimating. The smallest integer value for n. Oh! That's funny. They're cute. Okay. It's all in the wording. When we saw smallest, we assumed we were supposed to minimize the n plus first derivative. However, according to calculus, Lagrange says the n plus first derivative needs to be what? It needs to be the max. So the max would be e squared. They're asking for what's the smallest integer that the max could be. Ooh. I know, it's nasty how they worded it, right? Because smallest, you're like, oh, then I'll just minimize instead. No, 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 no. It's Lagrange. We still have to maximize. They tricked me on that one. We still have to maximize, but they say, what's the smallest? Okay, now that we have e squared, you're like, I don't know, it's 7 point something. Okay, cool. So what's the smallest integer that could represent e squared? And then we would choose 8. Because 7 would be below the actual error. So with the error, the smallest integer, the closest integer getting to that 7 point anything. We haven't gotten to 7 yet. Don't choose that one. We have gotten to 8. So then use that one. That's gnarly. They made us rewrite Lagrange, which we should never rewrite theorems. Let's just, I'll put that out there. But they made us think that we needed to rewrite Lagrange. Okay, do we now answer them all? Okay, listen up. If you have a question on 8, you're listening. If you think you can help and contribute to 8, you're listening. Otherwise, you're quietly working on polar area. And keeping out your packet for creation and manipulation of Taylor's theories, because I need to do a spot check before we leave. What is the largest error associated with the 7th degree Taylor polynomial approximation of... Oh, is this like built on some other question? It's bound to be, right? Okay, so the 7th degree is what's being used to approximate. Let me zoom out just a little bit so I can look at the same time. We're looking at the 8th degree term, right? And they did not give us the series or the function itself. Okay. They gave us the function itself and it was a graphing calculator. We might actually be finding the max, but since they didn't, we're just thinking Lagrange. So we could say the 8th derivative centered around 1. Oh, approximation at 1. Of 1. So looking at the derivative, one is the first derivative, 1/2. Negative 1 is the second derivative, because over 2 factorial. Negative 1 factorial. Positive 2 factorial would be the third derivative, because 2 factorial had to cancel with 3 factorial or reduce to get 3. Okay, and all of that for me to go ahead and look at this. The 8th derivative. They didn't tell us about increasing or decreasing, huh? Oh wait, we figured out what the function was. Gabby, what was your answer for number 6? That's so much easier. F of x is equal to, that makes way more sense. B as in boy? Okay, so we're dealing with the function ln of 1 plus x. Okay, nice. So then think about the derivative of ln. That'd be 1 over 1 plus x. Because we have to maximize, so we can't just steal like the 8th derivative at 0. So we have to actually find the 8th derivative. The nice thing is there's the pattern. We bring down the negative 1 for the 3rd derivative. We bring down a negative 2. Fourth derivative. We bring down a negative 3. So first of all, the signs alternate. Second of all, so for the 8th derivative, you can kind of just jump there and say, okay, the 8th derivative is going to be 1 plus x to the 8th, because the degree always matches, the first degree, second degree, third degree. And then on top, we have back and forth, back and forth. Every even is going to be negative, so we could put a negative. Every odd is going to be positive. And what we have for the top is, for the second derivative, it's going to be 1 factorial. For the third derivative, it's going to be 2 factorial. For the fourth derivative, it's going to be 3 factorial, 3 times 2. Then it's going to be 4 times 3 times 2 for the fifth. So this is going to be 7 factorial. If I'm looking at this function, it's an even reciprocal function, which is like this normally. But since it has the negative power, it'd be flipped. So its maximum would be to the furthest right. They're asking at 1. So, between 0 and 1, because 0 is where you're centered. So you would go ahead and say it's maximized at 1, or such that x equals 1, or z equals 1. So then we could say the 8th derivative at 1 equals negative 7 factorial. We could go plug that in, because they're asking entire error, which is the whole thing. So I'm plugging in negative 7 factorial. The 7 and the 7 factorial down here reduce. And that's all times 1, which would be negative 1/8. Ooh. Oh, absolute value. Thank you, thank you, thank you, thank you. You got a different way? It is alternating, so I guess we could have done the alternating series. The nice thing is it ended up being the same as Lagrange. I'm not sure that's always true. Alternating series isn't a maximum error. And this one it ended up being the same, because it was maximized at 1, but let's say it was maximized at 0, it would be a different answer because it wouldn't be at 1. Does that make sense? I'll just be careful with that. All right, kiddos. Just in case someone's going to be gone tomorrow, let's go ahead and pause on the polar area. If you guys could look up. I'm going to go ahead and show you guys what's in your folder. Uh-oh, if my computer decides to work. Okay. We know that we have now transitioned. Eyes up. To the board. Shoop, shoop. To the board, to the board. Hold on, Tom, Easton. Eyes to the board. Just in case someone's going to be gone tomorrow, you are without excuse. Because we are now in the AP exam review folder, yeah? We have officially shifted. Ooh, hey, even if you're not here tomorrow, we get the nice little pretty handout. What's online for you guys to use? Okay, we have forevers and endeavors that we need to be memorizing over break, quoting and or writing. There's the same additional way of meeting these requirements. Remember, if you do decide to handwrite them, it does work or is counting towards double. Did I put double? Yeah, double. Double quoting, and has to be attached in order to count. The check marks are strictly showing quoting, and there's your little integrity statement at the bottom. If you're gone tomorrow, print it out and you can still use it. That's due the Monday after spring break. Yes, Katrina? I think they're about the same.
The minimum of 10 minutes?
I said thoughtfully reading aloud, and I do not believe that you can read through all the forevers and the endeavors thoughtfully in anything less than 10 minutes. There's no way. 10 minutes is actually quite, probably isn't very realistic either. Okay. Oh, yeah. Yeah. Hold on. We don't have a lot of time, and I need to get through the rest of the logistics. If you have extra questions, ask me after. So, you will all be getting this handout tomorrow, but if anyone is absent, print it out, and it is due the Monday after we get back. There will be a large Forever Endeavor quiz after we get back from spring break as well. The Forever Endeavor final, remember, just happens a few days before the actual AP, right? In addition to that, you do have, remember over Christmas you had Barron's? Now what do you have? Spring break, a College Board, full-length exam, 2003. A full-length exam, 2003. The formatting is such that if you print it off, you guys know that the actual AP fits like 2 questions a page. I tried to find a formatting that fits a lot less. So the 2003 full-length exam is due attempted and graded. I'll put the solutions up just like you did for Christmas with Barron's. Okay? And you guys, it's up to you to do it in the correct process. You know AP stuff. I don't need to tell you calculator, non-calculator, etc., etc. Those are the 2 things over break. The practice exam I'll have due the Tuesday we get back, the Tuesday by the end of the day, because the Monday we get back, you will have your 3rd laying the foundation review due, which you will get tomorrow. So for tomorrow, polar area, do all the odds, grade them. The answer key will be online. Do all the odds of polar area. The answer key will be online, and we'll go through questions similar to today. I didn't spot check. On the way out, show me your last odd FRQ graded. Show me your last odd FRQ on the way out. Literally, be walking towards the door. Got it. You're my hero. Thank you, bud. I need to pause this.